Hello everyone, today we'll be doing the calculator section for the 2012 MCQ. If you haven't already, check out part 1 where I went through the non-calculator section. Make sure to subscribe and leave a comment if you enjoy these MCQ tutorials. Once again, these are very similar to the real AP exams, so I linked the questions in the description below if you want to try them out by yourself. Part B starts on number 76. We need f prime to be positive and increasing. First, f has to be increasing, so we have the points C and E. Then it also has to be concave up, meaning the answer is E. In number 77, we are given that the IVT applies and the points 10 and 20, so all values in between are guaranteed to exist. Our answer is A, which says that 13 exists. In 78, we can find where it crosses the x-axis by graphing the function on our calculators. We save the x-coordinate and then use it to derive the function at that point, and we get 2.961, which is D. For 79, we need to find average velocity, and the formula is 1 over b minus a times an integral from a to b of the function, so our answer would be B. Don't get confused by A, which gives the average acceleration instead of velocity. 80 asks us for which statements are true, so we should go through them one by one. For number 1, it's correct because f prime changes from negative to positive. Number 2 is false because it keeps on increasing. And for number 3, the graph is concave down for 0 to 4 because f prime is decreasing. Our answer would be E, 1 and 3 only. 81 gives us a rate in and an initial value, so we do 800 plus an integral from 0 to 20 of the rate. This gives us 1220, which is D. For number 82, all we need to do is graph f prime on our calculators and find the zeros. It changes from positive to negative at 0.35, so the answer is C. Number 83 asks us to find distance, which is the area under the curve of velocity. We count up each of the squares, and it equates to around 21. Remember that the graph goes by tens, so our answer would be 210 feet, D. In number 84, we find concave down by graphing the double derivative and seeing where it is negative. On our calculator, we see that the two intervals match the answer D. In number 85, we find local maxima when f prime changes from positive to negative. The answer would be C, 1. For number 86, it tells us f prime is positive, meaning f of x must get larger, so we can eliminate C and D. The integral is also equal to 0, so f of x has to have both positive and negative values to balance out. Only B fits this, so that is our answer. In number 87, concave down means f double prime is negative, so negative 2 to negative 1 and 1 to 3, E. 88 has kind of a related rates problem, so let's label the figure and write down what we are given. We have two triangles with one inside the other, so they are related. We can use 15 over x plus y equals 6 over y. We can set them equal to each other by doing 15y equals 6x plus 6y. After simplifying, y equals 2/3 of x. We can derive this and get 2/3 times dx and get 8 over 3. This is the same as b. In 89, we can use FTC to form an integral from 0 to 3 of a and set it equal to v of 3 minus v of 0. We can use our calculator to solve this and get our answer, E. In number 90, let's use a u sub, but use the letter t instead of a u. T equals 2x, dt equals 2dx, and dx would equal 1/2 dt. We can change the bounds by multiplying by 2, and we also replace dx. Our new integral becomes this. Multiply each side by 2 and we get an identical answer with b. 91 asks us what is true, so let's go through them in order. A says the table has to be concave up, but there's no way to tell that just from the table. B says that there's at least 2 points of inflection, and this is correct because it goes from 3 to 1 and then 1 to 4, and then 4 to 7 and 7 to 5. This is changing concavity because it changes from increasing to decreasing or vice versa. The last problem is number 92. It asks for the cross-section area for squares. We take an integral using the intersection points as the bounds, and then the top function minus the bottom function all squared. We know that square root of x and x squared intersect at 0, 0, and 1, 1, so we can take an integral of 0 to 1. Square root of x is the top function, so it comes first. If you didn't know this, you can always graph it on your calculator and make sure. Our calculator gives us the answer 0.128, which is A. That was the calculator section. As you can see, many problems also use graphs that relate f, f prime, and f double prime. It is important to not mix them up and know what they tell about each other. Calculator skills are obviously important, so make sure you are fluent with finding points of intersections and taking integrals or derivatives. If you have any questions or any topics you would want me to go over, make sure to drop a comment. Thanks for watching and subscribe to know when I post more calculus videos.